Hi, this is Isaac Higgins, reviewing my third and final research paper for the course Engineering Self-Adaptive Systems. This final paper is called Designing Robot Teams for Distributed Construction, Repair and Maintenance. It was written by Todd Wareham at the Memorial University of Newfoundland in Canada in July of 2019. There is an increasing need for an autonomous system or group of systems that do not require human supervision. As some jobs get more and more dangerous, or more numbers of robots are required, the more autonomous robots are needed, interactable with each other to allow human operators to control subgroups of robots rather than individual robots. Although there is already much literature about autonomous robotic systems, there is very little about robot teams, and even less involving more than just construction of railroad structures, such as repair or maintenance of these structures. Some reasons there is not much research and certainly no already built robot teams for construction, repair, and maintenance of structures include conservatism of the construction industry, where often people in construction understand how structures are built and are not ready to make drastic changes to these processes, and concerns over safe interaction with robots, where people are still untrusting of robotic systems, how they might react to unforeseen events, adaptability to environments, and what could happen if these autonomous robotic teams have control of large machinery or equipment, for example. There has been extensive work on suitable robots for construction in the past 3 decades, but nearly all of it involves a single robot solution that is either tele-operated, supervised, or semi-supervised. This is mainly due to concerns about the interactions between robots and humans in the construction environment. Various work has been done on the computational complexity of both verifying that a multi-robot system can perform a common goal and designing those systems for the task. But much of it assumes the robots being moved cannot sense, plan, or move autonomously. 5 papers to date incorporate both autonomous robots and an explicit model of robot architecture and environment, only 2 of which consider construction-related tasks. Both of these only consider the initial creation of structures and don't address repairing subsequent damage or erosion to those structures on either a one-off or ongoing basis. The main ideas the author had in this paper was around team-based structure manipulation, and that it was intractable or hard to control, and trying to understand what would make team-based structure manipulation tractable, easy to control. Both of these ideas and questions involved a lot of mathematical equations and algorithms to prove the claims being made in these topics. The basis of the claims made in this paper was that everything was calculated or worked out in relation to a 2D grid structure, where robots could move around and interact with adjacent squares in the grid, or squares adjacent to the robot's current location. The first idea mentioned earlier concludes that neither synchronous or asynchronous heterogeneous team design for construction, repair, or maintenance in given environments could be done efficiently for all inputs. The second idea concluded that any set of parameters can be restricted to yield tractability for synchronous team design for construction and repair. This idea may be better than other research papers on similar topics because this type of robot team design had not been studied to date in the literature. All results are derived relative to a model in which simple robots made in non-continuous deterministic manner in grid-based environments. And it is the start of a connection between robotics and computational complexity theory. The evaluation of the results in this article was in-depth and covered all angles. Much analysis was spent on the implications for simplified robot team design and implications for real-world robot team design. The first of which concluded that construction, repair, and maintenance problems cannot be solved efficiently in general. This is to say that the problems analysed in this article was not a true representation of the problems that may occur in the real world, and the solution may not be suitable for all real-world problems. The implications for real-world robot team design concluded that there were three difficulties when applying the results to real-world distributed robotics. These included the impractical runtimes of the algorithms underlying the tractability results, even if improvements were made to the runtimes, the algorithms are derived relative to simplified models of robots and environments. And lastly, even if more realistic models could be used, it is possible such models could still simplify aspects of the real world, causing robot teams to perform much worse when implemented in real-world hardware. It is claimed that although the analysis was done on a 2D grid structure, it is computationally secure and always allows for future research in more realistic conceptions of 3D structure repair and maintenance that allows more types and degrees of damage. All this indicates a significant robustness to the evaluation approach in this article. The only critique that I have for this paper is that it involved a lot of mathematical formulas and was hard to understand, not having the background knowledge necessary for the complexity of the algorithms covered. Thanks.